in module that I wrote up, right? So what did you discover? How do we create, okay? How do we create a new function based on existing function sine, such that the new function is 1 to 1, and then has an inverse, because only 1-to-1 function has inverse, right? We know that this function doesn't have inverse. It's not a 1-to-1. So the idea was to truncate, right? To truncate and create an inverse. And there are a couple of things we need to consider, right? When we call it inverse, what kind of inverse, right? For example, we know that e to the power x and ln are inverse function to each other. So what's being inverted? What is being inverted? Right?
Do you just switch the coordinates?
We switch the coordinate. What is the implication of switching coordinate? Very good answer, Bailey. What's the implication of switching the coordinate?
Switching the domain and range.
Switching the domain and range, that's correct. And what else? In terms of function, what else being switched?
The input and output?
That's right. That is the essential. That is actually at the core of this process. Okay, so let's look at sine cosine before we continue, right? We look at the input for sine. Right, we look at the input for sine. Okay, excellent answer. You guys got it. They're all, you know, switch domain and range, switch the coordinates, and what is at the core of this process, okay, is sine. I've been emphasizing since the beginning that sine takes the input of angles. So what does it produce? It produces a ratio. And this ratio, we call it sine. Okay, this ratio is called sine. So whenever you see sine of something, it's a ratio. You're looking at the ratio. What kind of ratio is this? Of course, we know this ratio has some special interesting properties. The absolute value of this ratio is less than or equals to 1, or right, it's between -1 and +1. Do you guys follow me? This ratio is between +1 and -1, or -1 to +1, okay? So when we switch, when we invert it, the input output swapped. So now the ratio is going to be the input for the inverse function, okay? And we can call this inverse function, actually we call this function different names, right? Some uses arcsine of the ratio, okay? Arcsine of the ratio. So the input for arcsine is a ratio. And the other notation that we use is sine of inverse, and they all mean the same thing. They all mean the same thing, okay? It's also ratio. And what will be the output? The output will be angles. Okay, so that at the core of this analysis, okay, if you look at this curve, we understood each pair of each point, right? Each point arbitrarily, right? Each point, we pick up arbitrary point, right? On sine curve. How do you mark this point? This point, the first coordinate is an angle. The second coordinate is the sine ratio for that angle. Okay, so when we swapped it, so what we know this function doesn't have inverse. So next we're going to create an inverse and create a function that has one. It is one-to-one function, right? Now the question is, like yesterday we talked about the idea of truncating, right? Or chop, chop, chop. In mathematics, we don't use the word chop. We don't use the word chop. We use the word truncation, truncate. Okay. You guys understand what's truncate, right? That word means what?
Chop, chop, chop.
Chop, chop, chop. That's right. It means the same thing, but we don't use the word chop, chop, chop. We use the word truncate. Okay. Truncation or truncate. Okay. However, you know, it's a verb or noun, whatever you call it, truncation. So how do we truncate this? Right? To get a one-to-one function that we know that it has to be for a function, okay, for a function, it passes the vertical line test, right? You guys understand that, passes the vertical line test. You draw the line, is going to pass the curve only once. Any line, any vertical line you draw, you cross the curve, you're going to pass the curve at exactly one point or no point. But to make a function, to make an inverse function, it has to pass also the horizontal line test. And sine function obviously does not pass the horizontal line test, right? But there are pieces that passes both vertical line test and the horizontal line test. Yes? So what are the pieces do you think we can truncate and leave it as a one-to-one function? Yesterday, my proposal, which is, you know, my proposal is truncating, starting from here, truncating all of these, right? Truncating all of these, right? So after that truncation, if you look at this piece, does it pass both vertical line test and horizontal line test? Does it? It does, right? But could I, if I clear all of these, could I use this piece? Right? Could I truncate that? Could I truncate all of these and leave this small piece? Could I do that?
Yeah.
Of course, right? You can. We have many options to do the truncation, right? Many pieces. Guess what has been decided by the mathematicians? They decided to choose the simplest piece possible. Okay, they decided to choose the simplest piece possible. So which piece is chosen? The chosen piece is a piece I marked yesterday. Okay, so what is that chosen piece? I want you guys to draw this curve on your paper. Okay. And mark some points, okay? Mark some points. Because the result of this truncation is not the inverse, it's a new function. It's a new function. It's a new function based on existing function sine. And this function will have inverse. And there's some other issues, right? There's some other issues. Okay, we're going to consider this one by one. And I hope you guys follow me patiently. Okay, so when we do this truncation, okay, we truncated this piece, these pieces, they're all gone. They're all gone, okay? And we save from this point, which is the highest point, to the lowest point, everything else gone, truncated. This is a new function, okay? So we're going to express this new function, and we're going to see how that inverse will be created, Okay, all of these are chopped off. So now, can you mark this point, these 2 points? Can you mark these 2 points? This one is negative pi over 2, comma, negative 1. And the highest point right here is pi over 2, comma, 1. The first one is input, the second one is output. Input, output. And you guys just mentioned this, you know, switch the coordinates, switch the input and output, switch the input and output. So the inverse function is going to be what? It's going to be what? Every single point, okay, you can see this P passes what? Both vertical line test and horizontal line test. So it's a one-to-one function, but we have to be clear about what these points are, right? All of these points, okay, I'm going to give you a typical point. I want you to mark this point for me, okay? Okay, I'm going to choose a start point. This point, can you mark this point for me? I'm marking that point. You mark these 2 points for me. Okay, this new function. Okay, we're gonna have a description about this new function. Did you mark that point? Do you agree with me? So this is the new function, okay? This is the new function created based on sine function, okay? Does everybody follow me?
Yep.
All right. So the new function obviously do not have the same domain, right? Does it have the same domain? No, you only keep, the domain is from negative pi over 2 to positive pi over 2. It's from negative pi over 2 to positive pi over 2, isn't it? That's a domain. Could you see clearly what's the domain and range? Yes or no? Can you see that?
Yep.
Right? The new domain, what is a new domain? What's a new range?
Domain is from -1 to 1, and then the range would be 1 to -1 and 1.
I don't think that's correct.
No.
Again, the new domain. Okay, I'm sorry, I just accidentally chopped off all of these points. Okay, the new domain for this truncated function.
Since regular sine, the domain is negative pi over 2 to pi over 2 and the range is -1 to 1. Arcsine would be switched. The domain would be -1 to 1.
That's right. That's right.
Yes.
Okay. The gentleman earlier, you reversed it. Okay, the domain is not from -1 to +1. The domain, I'm just talking about this function. We haven't talked about the inverse yet. This is not the inverse. Okay. Okay. This is the truncation after sine. So what you see is, how do you identify the domain of this truncated function? How do you identify the domain of this truncated function? Okay, forgive me, I just couldn't, hold on, okay, okay, you know how to mark the points. right? And I want to show you how to identify the domain right here. Okay. This, the horizontal is a domain. The horizontal is from where? We just marked the point, right? This point is negative pi over 2, negative 1. And over here, that's pi over 2, comma 1. So what is the domain? Domain is about the input, right? So the input, I like the lady just said, who said that? Was it Jesslyn?
Yes.
Okay, it's from negative pi over 2 to positive pi over 2. It's from here, that's the domain of the new function. Okay, that's the domain of the new function. And the range is from negative 1 to positive 1. You guys see that? So the new function we created, okay? The old function, what's the domain for the old function, for sine function?
Negative
Any angle.
infinity.
That's right, any angle, right? From negative infinity to positive infinity, you're right. Any angle. But after truncation, we get a new function. We get a new function. And what is being changed? Right, so let's see what's being changed. Okay, so after truncation, the domain has changed. Okay, after truncation, it's no longer any angle. Okay, this angle is going to be between negative pi over 2 less than equals to a less than equals to pi over 2. Okay, only this angle. Okay, and the ratio still the same. Do you follow me? Do you follow me? So the truncated function, however, is rarely used in our work. The truncated function actually is rarely used. Okay, so then some people will say, oh, you see sine has a function, sine function, and this is truncated function after truncation. So when you say sine function, which function do you refer to, right? That could be confusion, right? Well, in 99.999% of the cases, when we talk about sine, we still talk about the function as we knew, which is the input is any angle, the output is between negative 1 and 1. Do you follow me? So this is like in the background. This is like in the background. Now, we're creating this function that's the ratio is the input, right? Arcsine takes the ratio, it produces angle. So according to the inverse function relationship, what will be the ratio? What will be the, what's the domain of arcsine then? The domain of arcsine would be what?
Negative 1 and 1.
That's right. That's the perfect answer. That's the perfect answer. Okay, so the domain for this ratio would be between negative 1 and 1. Okay, so I'm going to write it down as ratio between negative 1, 1, or you have all these different ways of expressing it as ratio. Okay, narration. This ratio is going to be between negative 1 and 1, less than equals to 1, all these different forms, okay? All these different forms I'm going to give you because I will be testing you. Okay, I will be testing you left and right over and over again. All these different forms. okay? Don't tell me I didn't tell you, okay? The input for Arcsine is going to be a ratio. The ratio is going to be between -1 and 1. Sometimes the ratio will be replaced by x, okay? And that kind of ratio will be the input for Arcsine or sine inverse, okay? These two notations are used interchangeably, okay? So now I'm going to clean this up a little bit, right? It's a kind of, and what will be the angle produced? What will be the output? The output will be between -pi/2. You guys see that? Between -pi/2 to pi/2. Okay, well, of course, we have a lot of issues to answer, but right now, do you understand this inversing process? Does everybody understand this inversing process? Do you? Now, the inversing process. Okay, so now we're going to plot some points. We're going to plot some points. Okay, we are actually going to create the graph. We are going to create the graph. Okay, so what I'm going to do, I want you to do this with me. I want you to do this with me, because I believe that most of you probably have never done this before. Okay, truncation. So I'm going to truncate, right? We know the truncation. So I'm going to see, we marked some points, didn't we? We marked some points. Okay, so what are the points we have marked, right? So I'm going to set a table. Okay, you guys are going to work with me patiently. Can you work with me patiently? Okay, we're going to look at the input for sine, for the truncated function, the output. Okay, this input output is for which function? For this function. Okay, this truncated function we rarely use, but today we're going to take a close look at it. This is truncated function. Okay, so this truncated function, I'm going to use a simple, somewhat simple. I'm going to put it here. Okay, and the input is a ratio. The input, I'm sorry, the input is here. Okay, the input is here. And the output is going to be from -1 to 1, right? That's a sine of A. Is between -1 and +1. Okay, it comes with all these different forms, and I'm not going to write all of them together. And the points, right? And the points. The input, output. These are related to the homework I assigned you. You understand that? These are related to the homework I assigned you. Okay, so now the input. Okay, input output. Okay, so this is about the truncated function, and the input are angles, right? So I have just given you -pi/2, -pi/2, and you're going to give me the output. Okay, I'm going to give you several numbers. I'm going to give you several numbers, so you get to, use your, you got to show me that you remember some special angles and stuff, but they're really not terribly important. They're really not terribly important. So I'm going to give you like a -pi/3. Okay, and you have that unit circle in front of you. Okay, if you don't remember, it's not a big deal. Okay, if you don't remember, just refer to the unit circle. Okay, I don't really consider memorizing those numbers is terribly important. Okay, so pi over 6 negative. Okay, I'm going to keep the table going. Insert some more rows. Okay, and 0, right? And then it's pi over 6, pi over 3. Okay, and oh, pi over 4, sorry, pi over 4, and then pi over 3. So I'm just giving you more rows. Does everybody follow me? Yes? Okay, just be patient with yourself. I assure you, you don't have to do this very many times, but if you do it, it really gives you a lot of insight. It really gives you a lot of insight. Okay, pi over 3. And the last one is pi over 2. Okay, I don't need this row anymore. Okay, you can see I arrange these numbers in a certain way. Okay, and the output, you're gonna give me the output and you're gonna make those points. Okay, and we're gonna plot those points. We are gonna plot those points together. Okay, we're gonna plot those points together. Did you write them down? So I got this rectangular system here. And I really don't like the way they set up the label. Let me see if there's anything I can do. Labeling, axes. Hopefully this is cleaner, okay? This is a cleaner. So you should have a rectangular system in front of you. I want you guys to plot these points. You guys are gonna be plotting these points, okay? Did you get the output? Just do one by one, right? This is a time to review because this is what the support class is supposed to do, right? This is one of those things support class is supposed to do. And even though we kind of mix them, together, but this is the 2 hours we're gonna spend, right, to do these very basic things, okay? And I sincerely hope that everybody follows me to do these very basic things. This really covers, a major part of your homework, which I assigned you yesterday and the day before. Okay. And next, we're going to plot these points. Okay, so you have a realistic sense. Okay. What's the input? What's the output? First-hand experience. Okay, first-hand experience. Okay, and then the next part, of course, we're gonna get to the unit circle. Okay, the unit circle. So hopefully I'll give you more tools. And once you understand this, you never have to remember a lot of things, really. Okay, that's the goal. Okay, you never have to memorize a lot of, stuff. Okay, numbers. So the points are, these points are input, output, input. So when you do this, I want you guys to do it in the similar rhythm as I do here. Okay, this is the input. The input is angle, the output is ratio. Okay, and the way we write it, right? Angle, ratio. Input, output. Okay, so when you do this, think about this, input, output. Input is angle, output is ratio. 0, 0. Okay, so more points. Once you do it, you realize it's pretty simple. You'll never be confused, I hope. Okay, you will not be confused ever again. 3. I'm sorry, I made a mistake somewhere. Okay. Root 3 over 2. This should be root 3 over 2. Why did I do that? Okay, so this is positive root 3 over 2 over here. And pi over 2, comma 1. Okay, so we got all of these points. And next, we're going to plot them one by one. We're going to plot them one by one. Okay, so add items. Red dot. Maybe I'll make them black dot. I'm going to make it black dot. Okay. Negative pi. Negative 3 pi over 2. This is going to be 3 over 2. Negative. One more. Negative 4. Approximate those points, okay? Approximate those points. If necessary, just get a decimal number, okay? But do it. And this is pi over 6. And this is 1/2, negative 1/2. Let me check if I got them right. Yeah, it looked like they're fine, right? They're good. Keep going. And so this time is going to be positive. Oh, positive. This is going to be 6. And this is going to be 1. And this is positive. Okay, so I'm going to put this here. Over here, there's a 0, 0. I should not have forgotten. And pi over 4. And this will be root 2. Two more. Okay, 3. I'm manipulating this software, which is, scientific notebook, but you're doing it on your paper. Okay. Wait, what did I do wrong? I think I would know what I did wrong. I got the point.
Isn't the negative pi over 4 negative 1 over square root of 2 for the output?
Did I miss that?
This version is just so that the square root isn't on the bottom. So it's been multiplied by the square root of 2.
Right, it's being
On the-
rationalized. It's rationalized.
Okay.
Same number. This one, I should put a point here, and this would be a point. Okay, so add one more item. It's pi over 2, comma 1. Did I forget my 0? 0, comma 0. A point. There. This is basically the sine curve, right? But after truncation, yes? So I want you guys to mark each one of these points, okay? I want you guys to mark each one of these points. Are you there? You mark each one of the points. Now, the fun part, the inverse function, okay? We created this table. Right? We have done all those prelude, right? About, logarithm, exponential functions, and inverse functions, and so on and so forth. It is for this moment, right here, right now. Okay, so let's look at the inverse function. So I'm going to take this table. Okay, I'm going to take this table. I'm making a similar table. I put it on the other side. Okay, it doesn't make it, it does. Okay. And I'm going to switch the input output. Okay, so what does it mean? What's being switched? Domain and range are switched. You guys said the same, you guys all said it, right? So let's do it. So this one will be put here. And this is going to be the ratio. Okay, this is going to be the ratio or input, and the other one will be the angle. Output. Okay, that's the output. Output angle. Okay, so over here, I'm going to put the input over here. Input replace ratio. Okay, but you know that input is ratio, output is what? And I want you guys to physically do the switch. Do you follow me? You said it's a switch, right? Swap X and Y. So now let's do it physically. So these two switch places. Okay, that's what it means. Okay, so negative pi over 2 will be the output. Negative 1 will be the input. Could you guys do that for me one by one? So one sentence, one phrase has so much implication, Okay. That's what the swap is. You swap input and output. So we're swapping input and output. That's what we're doing. I'm doing it. Could you do it, please? I hope that I hope you don't feel this is beneath you. Is this beneath you? No? I hope so. I know some people may get bored and say, I don't want to do this. This is just too tedious. Okay, and 0, 0 swap, that's no difference. But even though the value is the same, the meanings are different. So we have all these swaps, right? All these swaps. This 0 was a degree. Now this is the ratio 0. Do you guys follow me? even though these two zeros, this is a ratio 0, and this is the ratio, this is the angle. Do you guys follow me? Input output swapped. Okay. And next. Okay, so let's just finish this. I think I already did it, right? I already did this ratio, and the more ratio swapping with the input. There. Okay, and of course the ordered pair will be swapped as well. To tell you the truth, I didn't do this with my trigonometry class. I hope they got an idea. Okay, I will find out. Okay, I will do some investigation. So the input output was swap, right? So this is also there's a swap. Okay, so let's be patient. Let's do it one by one. You know what's going to be amazing is after you do this. Okay, after you do this, it will do some miracles for your subconscious. Okay, at your subconscious level. And you will be not making those mistakes we saw so often. We saw so very often. Okay, 0 and 0 swapped. Okay, I'm actually going to swap it even though they're the same number, but they have different meaning. They have different meaning. Okay, one is ratio and the other one is angle. Ah, we're done. Okay, do you follow me? Could I see that you guys can plot these points? Okay, still input output in the same rectangular system, okay? So we're gonna plot these in the same rectangular system. And this time I'm gonna use red dots. Red dots. If you have any questions, hold your question, okay? Just I will get those, you know, I'll get to your questions. This is gonna be 0, 0. You know what? I need to go back there. I forgot to do something. Okay. This should be a red dot. Red dot. I hope I didn't mess up. There's a red dot. This is going to be a red dot. And this is going to be a red dot. And this is going to be a red dot. Adding So this is going to be red dot, more red dot. This is 4. Okay. And this should be negative, and this is going to be positive half. 6. Last. Positive 1. Pi over 2. Okay, let's see if I have everything. All right. Red dots. Do you guys see that? And I want you guys to mark every dot on your paper. I want you guys to mark every dot on your paper. Could you do that for me? Because I will be doing as many as I can, so it will look, clear enough, right? The black one, excuse me, is a consequence of truncate. Excuse me. Okay. Over here. This black one, it was pi over 2, comma 1. This red one is 1, comma pi over 2. Do you guys see that? Yeah? So I want you to mark each pair to see how those input output are swapped. That is the inverse, okay? Inverse reverting input and output. And the new function is still a one-to-one function. Okay. And now marking another point. Okay, this is a black one. Oh, I'm sorry, I made a mistake. Apologize, I made a mistake, okay? Hold on. I made a mistake, I apologize. I made a mistake, sorry. This dot is negative pi over 2. Negative 1, okay? My bad, totally. Okay, and this other dot, okay, I'm gonna use the color tone, red. And this is gonna be negative 1, negative pi over 2. And this point, the red, is a negative half, negative pi over 6. And this red is 1/2 pi over 6. This one, this red, is 1 pi over 2. Now, black. Okay, so this point is pi over 2, comma 1. And this black point over here is pi over 6, 1/2. negative pi over 6. Negative 1/2. I'm not marking all of the points because that would be so messy, but I give you these examples, but you are expected to know that each points, how are they corresponding to each other. And last but not least, we're going to connect the dots. We're going to connect the dots. You guys done? I try to use these color coordination. Okay, the red is for the red dot. Okay. Any questions? Any questions? Any questions? Okay, so I'm gonna connect the dots. Okay. Are you done? Everybody?
Yes.
Good. Do you think you have a better understanding?
Yeah, much better.
Thank you. Any questions, please? There was a question earlier on about the square root of 2 over 2 versus 1 over square root of 2. Is that still a question? Is that still a question? I will address any question you have in this process. But right now, let's just get this done properly, because if I move around too much, it's gonna create this problem. So I want you guys to plot all of these points. Let me clarify, okay? The black and the red, the black and red, the black and red, they are each on their own function. The black is a sine and the red is arcsine. But you can see the inverse process. One's domain is the other's range. Just in terms of function and its inverse, it's consistent with the inverse for e to the power x and ln x. Do you follow me? always the same. However, the sine function after truncation is rarely used. Okay, it's rarely used. So whenever you see sine, you refer to the sine as we knew, with any angle as input and the ratio is the output. But whenever we mention arcsine, the red curve is what we are talking about, with domain from -1 to +1, range from -π/2 to π/2. Okay, so I'll be giving you the various forms of description. Okay, those various forms oftentimes get our student very confused. Okay, get our student very, very confused. I hope to resolve these issues once for all. Okay, as those mistakes I've seen in Math 190 when I taught it, or Math 191 when I taught it, and you know, variety of confusions and stuff like that. Okay. Are we done? It's a lot of work, right? So if you look at the homework I have assigned you, we have done a big chunk of the homework. We've done a big chunk of the homework. And next thing I'm going to draw, okay, is that property that reflected for inverse functions that are to each, you know, function that inverse to each other. They are symmetrical along that green line, okay? And that green line is what? That green line y equals to x. Just like e to the power x and ln x, right? Just like e to the power x and ln x, they have that property. In fact, in mathematics, when you talk about inverse functions to each other, they all have the same property. One's domain, the other's range, symmetrical along the line y equals to x. And the points switching the input and output. Do you follow me? Do you guys follow me? They have the same property. So now you probably understand why I introduced those properties earlier on. Okay, so if you make a connection, you see what? You see consistency. You see consistency. All right. So do you have any other questions before we take a break? Shall we take a break? Is that a lot? We're not done yet. Okay, I want to cover this function thoroughly, and we're not done yet. Okay, of course, I also promise you we're going to go over quiz number 4 very briefly, and we're going to leave that, you know, on the latter part of today's class. Okay, I will keep my promise, but it's going to be very brief. Okay, because it may not be necessary for us to go over the entire thing. Okay. So let's take a break for 10 minutes to come back at 9:10. Okay, so break 10 minutes, back at 9:10 a.m. Okay, so I'm going to, there's some chat questions. Axes of symmetry, what would be the, what's with the two tables? Okay, Sana. Okay, I will come back to answer your questions. Okay, if you have those questions, we will come back in 10 minutes. Okay, I'm gonna pause the record. All right, guys, welcome back. I saw some questions on the chat, so let me answer those questions. I apologize that I wasn't looking at chat when I was plotting. So Okay. At 8:43, Sana asked me what's with the two tables? What's with the two tables? I will show you the two tables side by side, okay? After, you guys have all of these down. Okay, did you guys write all of these down? And it's particularly important that you did it yourself. Okay, you did it yourself. Okay, and I will be continue doing this to, to go over the notations and common mistakes and so on and so forth. And Kyle commented, okay, Cortland says axis of symmetry. So what do you mean, Cortland? You said axis of symmetry. Do you mean the green one? Do you mean the green curve? The green line, sorry.
Yeah, I was talking about the green line.
Yes, that's correct. Okay, very good comment. And Kyle, you said we are graphing a normal sine function table 1 and then arcsine. Okay, we're not graphing the normal sine. We're graphing these two functions that are inverse to each other. In this case, the sine, well, the table 1 is a part of the normal sine. Okay, we actually don't use the word of normal sine. In the future, whenever we say sine, we actually refer to the sine. Maybe it's your normal sine. Okay, I'm gonna specify I will summarize and specify that what is the sign we refer to and what is the sign that after truncation. As I mentioned a few times already today, the truncated sign, okay, the sign after truncation, after the chop, that function is rarely used. R-A-R-E is rarely used. So you rarely use it. Okay, in your entire academic career. Okay. So we don't call it normal sine. It's just this truncated sine is the true inverse of the arcsine. The sine as we knew it, as we know it, is not the inverse of arcsine. Do you follow me? They're not inverse to each other. We'll summarize these. So did you guys have all of these points marked? I assume you have done it. I'm going to clean this up and we go on with other stuff. Do you follow me? Could I clean this up? Hello?
I have everything down. You can erase it.
Okay, how about everybody else?
I got it also.
Any questions? So please, if you don't feel comfortable to ask questions to everyone, you can privately message me, or you can even message to my cell phone. I have my cell phone by my side, and any way that make you feel comfortable. Okay, I want to answer your question. Okay, and I always appreciate your question. Okay, so now it looks like everybody says, well, not everybody said yes, but it seems that no issue so far, right? So I'm going to clean this up. We spent time on this. I'm going to be addressing that question by Sana. Sana, I'm sorry, did I pronounce your name right?
It's Sanat. A lot of people mess it up. So however you say it, I'm probably used to that way because somebody's already said it before. I just was lost a little bit because I was writing down the chart to the left and then all of a sudden we pulled up a chart to the right. And so I'm a little confused on what that chart is for.
Of course. I'm going to clarify. Okay. So did you mark the points?
I did.
Okay. Thank you for clarifying that. I hope I don't embarrass you by calling you out because you posed that question to everyone. Okay.
No, you're good.
Okay. You see that the chart on the left, my left, okay, is the black dots, is the truncated sign. The
Okay.
chart on the right,
Uh-huh.
on my right,
Mhm.
is a red curve, which this is the arcsine.
Mhm.
Do you follow me? This is the arcsine, which is the consequence of inverse. Okay, because the truncated sine has inverse.
Okay.
That inverse, the meaning of inverse is reverting the input and output. In the previous table, on the table on the left, the input now becomes output.
Okay.
You got it?
That makes
So
sense.
we recompose those points and we made the red dots. The red dots connected the dots, and that is the curve of arcsine or sine inverse.
Okay.
You get it?
Thank you.
All right. So next, I'm going to put these two tables side by side, just in case you missed anything. And I'm going to introduce more notations, okay? So once you understand this, that's not the end of it, okay? Because usually in your math classes, in your calculus classes, your teacher is not going to do this, okay? They're going to be giving you other questions using notations. So the notation is the next thing I want to get to. Those are the things that will get you the points. Do you guys follow me? So the next thing I'm going to cover is really, really important as well. You understand what's going on about inverse function, the relation between input and output, right? The next thing you need to understand is how to write it down to show the work so that your professors will give you points. Okay, I'm doing this because I've seen so many mistakes in my calculus classes. Okay, that's why I'm going to make a special point about this. All right, so now I'm going to really clean up. Okay, clear all drawings. I'm doing this a little reluctantly and delayed because we spend time doing this, right? I spend time doing this. Otherwise, I have to do it all over again. I make sure everybody got this. Everybody got this. Okay. Clean. All right. Notation, notation, notation. Okay, so math is not only about understanding, it's also about a notation. It's also about notation. For example, how would you know, in here, the input and output is made of the angles, right? The angles and sine of A, right? So those are the points. Those are the points. When we see this point, we'll typically write it as, okay. I'm going to put it just by its side. Okay, here. I'm going to put it here. Okay, so this way we still have this compact form for us to compare. Okay, what I'm going to do is I'm going to put this picture away, maybe on top of it. I still want to save that picture. Okay, so now notation. What kind of notation your professor wants to see? Okay, sine of negative pi over 2, this is the kind of notation your professor wants to see. I mentioned earlier that you never write sine alone. This is the proper use of notation. This is the proper use of notation, okay? And the next one would be sine of that equals to this. This is the proper notation. It's often related to these points. Do you follow me? Now, on the inverse function, however, okay, the input usually is called x. Okay, so I'm going to insert a row. So we still have the original row. We still have the original row. But I'm going to add on it. Okay, the input is usually, if the input is called x, which is often used, okay, right? And the output, we use a new notation. It's called an arcsine of x. You know, x is a ratio, right? X is a ratio. And the other notation, which is even more popular these days in recent textbooks, is sine inverse of x. So these two notations are used interchangeably. Okay, these notations are used interchangeably. Of course, one is, the range is between negative pi over 2 to pi over 2. Now, how do we write it, right? How do we write it? After these notations, this is the name of the functions being introduced, right? After the name of the functions being introduced, we're going to write arcsine of -1 is equal to, okay? This is one way of writing it. You guys follow me? Indicating the input, for this input, the output is negative pi over 2. The other way to write it is sine inverse of -1. Okay, so now in class, I want you guys to take your time to write down these notations following my example. Could you do that? Just do this several times, you'll get it. You will never make mistakes I have seen before. Do you follow me? Write it this way. Every math professor will understand and know what to expect. Or you write it this way, every one of you math professor will understand and know what to expect. The proper way of writing these understanding, you understand it now, right? But you have to use the right notation, write it correctly to really get the points you need for your good grade. Okay, so keep going. The parentheses I have there are necessary. When the parentheses are not necessary, I usually don't write it down. Do you follow me? So these parentheses are absolutely necessary. But these places, the parentheses is optional. So I don't write optional. Okay. So when it's optional, I don't write it. Okay. It's important to know when to use parentheses, when it's not use parentheses. Why? Wait until you start writing programming. You still write programs. You're starting writing code. Sometimes you have so many parentheses. It's hard to match them up. It easily causes syntax error, word calculation error, and so on and so forth. So you don't want to use too many parentheses, but you also want to use just the right number of parentheses. And they're always paired up. They're always paired up. Okay, so I'm trying to get you into that habit. Mathematics is one thing, and the other thing is the proper use of notation. The proper use of notation. The proper use of notation. So any school you go to, you are gonna get those points from your professors. Okay, they're typically very particular, but their particular expectation is very consistent. Okay, their particular expectations are typically very consistent. because those are mathematical conventions. For example, these parentheses, not necessary. Remove them. But if you put them there, is it wrong? No, it's not wrong. It's okay. But if it's not necessary, why should I write it? Right? To make it nicer and cleaner. But these these, because of the negative sign, you must put a parentheses. You must put parentheses. So let's look at the other side. Okay, let's look at the other side. Okay, I want you guys to write them down. Write these down by your own pen. Okay, on your own paper. Okay, make those hand-eye coordination and make those movements so you will not make those mistakes that you will later regret. That's the proper way to write it. Okay, that's the proper way to write it. On the second table, you usually you don't have to write both. You don't have to write both. Are you guys with me? You don't have to write both. One is enough. But because there are two notations that are used often, and this one actually have become increasingly more popular these years. So I will, I give you this option. But for you to show your work, you only have to show one of them. Do you follow me? You only have to show one of them. And we continue this, okay? I want every one of you to write this down today, right here, right now. The proper notation that will make your professor happy. And when she's happy or he's happy, well, you're gonna get points. Does that make sense? Understanding, notation, proper way to write. Any questions? Any questions? And it's going to be the same for cosine, tangent, cotangent, secant, cosecant. But sine function is very often used. It's very often used. Okay, today we just finished the sine. I think that's and then I'm going to go over a little bit about quiz number 4. Okay, but I'm going over quiz number 4 after this. No, after this, I'm going to do a summary though. I'm going to do a summary, okay, of these 3 functions. Okay, of these 3 functions. So did you write it down? Make sure you write the proper notation. The proper notation after your understanding is the way to get the points for yourself, okay? Any question? No? Are we good? Right? Okay. Now, summarize. Okay, summarize. Okay, with all these things said and done, okay, we're going to look at these functions. We're going to look at these functions. One function is sine of A, right? When we talk about this function, domain and range. Okay, domain and range. So whenever you talk about sine function, the domain we meant is the from negative infinity to positive infinity. Okay, there's no such word called normal sine. There's no such word called normal sine. The sine we refer to is always this function. The range, okay, the range is that. Okay, so you can see how many times I'm doing this, right? How many times do I write this down? It's absolutely important. As I told you, I'm going to test you left and right, you know, over and over again until you completely get it and ready for your calc. Okay, so this function is always what we refer to. Okay, and the other function is, of course, the sine inverse. Okay, sine inverse x. Okay, or arcsine x. Okay, these are the notations you will often see. And you will probably see this notation as well, using x here. Okay, that's what you often see. But here, I'm going to use a just to be consistent with my previous notation. Besides, these symbols really don't matter at all. These symbols don't matter at all. What determines the meaning of the symbol is the function that applied to it. Do you follow me? So when you have an a, when you have an x, suppose I put an x here. If I put an x here, you should not think this x and this x are the same. No, they're not the same at all. So what set them apart? These axes just a placeholder. I can totally use, you know, let me use some other notation, right? Let me use like, I'm gonna use a heart. How about that? Right? So this will be a heart. But what's the nature of the heart? The nature of the heart is determined by what? By the symbol, which is the rule. This rule determines the nature of the heart. Do you follow me? So that in that sense, we see these are just placeholder. Okay, so if I use that placeholder, which is commonly used, right? Now, this x, however, is dictated, the role of this x is dictated by this rule or arcsine rule. So this x domain is going to be absolute value of x less than or equals to 1, between -1, because it's a ratio. Okay, less than equals to x, less than equals to 1. And the range, what is the range? The range would be, okay, I'm going to give you all these different forms, okay? And these absolute value greater than equals to negative pi over 2, smaller than or equal to pi over 2. That's one form. Okay, I'm going to give you all the forms. And then I can test you and you have no excuse not to get them right. That's the idea. Okay. So you'll not be able to come back to tell me, hey, you never covered that. Well, I did. All these forms you must be familiar with. They're all saying domain and range. They're saying the same thing over and over again in different forms. Do you need to recognize all of them? Yes. Otherwise, you will not be able to follow that particular textbook or a particular professor. You don't know which one they prefer, right? They may prefer using this form, that form, and so on and so forth. And then you get lost. You stare at the symbol for 5 minutes, and there you go. The professor is on the next chapter. You can't follow. Do you follow me? You don't want that to happen. Okay, so these are the, whenever we talk about function, about sine, arcsine, these are the two functions we meant by convention. So you don't need to say, oh, this is normal sine. No, this is sine. There's no such a word called normal sine. You're not going to find that word in any textbook. Okay, when we say sine, we refer to this sine. When we say arcsine, we refer to this sine. Then you say, how about that sine we talk about today, that after truncation? Okay, the sine we talk about today is rarely mentioned. Okay, that sine is rarely mentioned. Okay, this sine with this is specific domain and with the same range. Okay, truncated. Okay, so let me give it a word, truncated. Okay, some is called restricted. Okay, restricted. There are all these different words. Restricted. It's rarely used or mentioned. Do you follow me? Okay, so remember this word, remember these I said. So that's why, okay, in real applications in your entire academic career, what you need to know is that these two functions are not inverse to each other. They're not inverse to each other. See, their domain and range doesn't satisfy that kind of situation, right? So now, graphically, if we only look at these two functions, right? Forget about the third one. The third column is rarely used. So what are we gonna? What do you need to know? Right? So I'm gonna bring back my picture here. I'm gonna bring back my picture here. Okay. And now I'm going to Open the views. Okay, see -10, +10. You probably saw this pic. You probably saw a similar picture in my posting, right? This is the sign we refer to, and the red one is the Arcsine we refer to. Do you guys follow me? Do you guys follow me? Yes? So let's see, there's a new message here. Yes, good, good. Okay. But if someone asks you, what is the inverse of this Arcsine? Then that's the moment you're going to refer to, oh, you say this is the guy, right? The third column. The third column. But it's rarely used. Rarely anybody asks you. But anyway, any questions so far? Any questions so far? If you don't have any questions, I'm going to go to the next part. Okay, remember, the question we had yesterday. Okay, the question we had, I gave it to you yesterday, is, okay, if you refer to the unit circle, okay, if you refer to the unit circle, so now I'm gonna bring my unit circle here. Okay, I'm gonna bring my unit circle right here. Okay, does the entire unit circle, of course, corresponds to the black curve? How about the red one? So what is the restricted function? If you look at the restricted function, which piece of the unit circle should be truncated, right? Remember we did the chop, 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 right? Which part should be truncated? Did I make my question clear? No? Okay, let me do it again. All right. I just want to give you another venue. Okay, give you another venue to understand this, right? So remember we did that table, didn't we? This table, right? The truncated. This unit circle, right? I'm going to put this unit circle together. Okay, here. The unit circle and this table. Come on, guys. Come on, come on, come on, come on, come on. Okay. Over here. Lots of information, isn't it? But I hope I make them complete for you. Here's the unit circle. Here's the unit circle. And here's the table we made for the truncated sign. Okay, even though we rarely use it, but since we use it today, let's make it thorough. Let's make it thorough. If you look at this table, right, and the other table, okay, and the other table, we know they're inverse function to each other, right? Sorry about that. Okay, these two tables we just worked with, right? Which piece of the unit circle do you think we do not need for these two tables?
Is it quadrant 2 and 3?
That's right. That's right. That's a perfect answer. Wonderful. Okay. So this will give you another venue, right? So these two quadrants For inverse function, it's not needed. We cut it off. We cut it off. Okay. Trump. Right? There you go. From this piece, you get all the ratios covered, all the ratio from -1 to +1 covered. All the angles between -π/2, between -π/2 to +π/2. Right? You see all the ratios are covered. All the ratios are covered inverse. So this is the piece of unit circle that make that a 1-to-1 function for these two pair, for this pair. You guys get it? Does that make sense to you? So when you work with Arcsine, okay, when you work with Arcsine, you can look at this too. You can look at this too. How do you use it? Right? For example, you say, I want arcsine of -√3/2, right? And what do? -√3/2, where is it? -√3/2, you're gonna look for the red number, -√3/2. Sorry, I used the wrong arrow. Okay, right here. Okay, so I'm gonna write it down somewhere. Okay, suppose I'm interested in arcsine -√3/2. Okay, I will rewrite this in better notation, okay, because this software doesn't do that. So you're gonna look for -√3/2. You follow me? And right here, because sine is a red number, right? And that's the input for arcsine. And what you do is that you're gonna find the angle. Your answer for arcsine has to be between -π/2 to π/2. So now from here, you're gonna draw that unit circle. You're gonna draw that terminal, and the angle is measured from standard position. The angle is measured from standard position right here. That is -π/3. So the answer is going to be -π/3 and that's your answer. And how many answers do you have? One and only, because all of these are 1-to-1 function, meaning what? Whenever you use arcsine, your answer is always one and only. If you give me two answers and one of them is right and the other one, and if you give me two answers, even though one of them is right, you will get 0. You guys follow me? You're gonna get 0. Why? Because you didn't understand it should be 1-to-1. Do you follow me? All right, with all of these being addressed, okay, we're closing to the end of the class, and let's talk about quiz number 4. Okay, let's talk about quiz number 4. What about the square root of 3 in the third quadrant? We truncated, right? We truncated, right? The arcsine angle, the range is between -π/2 to π/2. So your answer should never be outside the -π/2 to π/2. Okay. Yes, you do have this -√3 over 2, right? But that angle is not for arcsine -√3/2. Do you follow me, Kyle? Because we truncated. So for arcsine, okay, the answer is one and only. If the input is in the domain and the output must be in the range. So unlike e to the power x and ln x, those domain and range are naturally formulated. But for arcsine, the inverse function is imposed on by putting restrictions, Therefore, okay, so let me write this down. I'm going to clean this up. Okay. I'm going to clean this up. Okay, I'm going to put it on the top. Okay. You have seen this, right? Arcsine -√3/2. There's only one answer, right? When you say arcsine -√3/2, the answer is -π/3. That answer, this answer is unique, meaning one and only. Did you get it, Kyle?
Yeah, I understand now. Thank you. I thought I was just looking at it in a different perspective because I thought we're still looking at it from like a counterclockwise position, but we're not.
Different perspective. We will be.
Yeah.
We'll address those different perspectives later.
I'm lucky.
Okay. So right now you need to understand that the inverse function must be 1-to-1, meaning for one input there's a unique output. Unique means what? One and only. There's no second one. If you give a second one, you get 0. Got it? Okay, so now we have 5 + 7, 12 minutes left. I'm going to quickly go over. Okay, I'm going to quickly go over the quiz number 4. So if you have any questions you want to bring up on quiz number 4, please don't hesitate to bring that up. Okay, so this is going to be today is March 4th. Okay, so I'm going to put this away. I'm going to bring back up the quiz. As I'm bringing back the quiz, okay, I'm bringing back the quiz. Quiz number 4. Okay, what is the intention? Okay, so I want you guys to get your get the definition of Okay, to get the definition. I'm only going to cover 1 or 2 examples. One examples, if that's enough, I would just do 1 examples. And because I want to have something else to show you. Excuse me. The use of definition is at the core of this quiz. Okay, the use of definition at the core of the quiz. And ARD is at the core of this quiz. Okay, so A is the angle measurement, R is the reference angle, and the definition. So primarily you're using definition. For example, if I ask you for secant sigma, you need to find out what is the terminal of secant of sigma. Sigma, of course, is the terminal on OD. This is OD. And now what you need to understand is that this first number is x, y. Okay, so x is 4, y is -3. R of course is going to be what? R is going to be 5, right? Everybody knows that. And so what you need to compose is you're going to compose a secant sigma. Okay, sigma, I'm going to use this little drawing here. I'm going to write it down. This is a sigma. Okay, equals to, and then you follow the definition of secant. Secant is R, okay, R over what? X, right? You follow me? R over X. R over X, you plug in, and R is 5. X here is 4, because X is 4, Y is -3. Do you follow me? So this is 4. So the answer is 5 over 4. In the answer I give you, this one has another precise value, which is 1.25. So both forms are given to you. Either form will get you the points. Either form will get you the form. So some people ask me, do you want a fraction? Do you want a decimal? No, I don't care. I don't care whether it's a fraction or decimal. It's all being programmed in there. But what I wanted is a precise value. Okay, so to illustrate that, I'm going to show you, what if I want to find out? So let's look at another question. Did you guys get this one? So I just want you to use definition. And I don't even require you to say, oh, you make it a mixed number or what. I don't care. I just 5 over 4 is fine with me. Okay, this is not an arithmetic class. And I'm not going to worry about, you know, how to convert a fraction to mixed number. I assume you knew that. Okay, so next I'm going to move forward to show you what I meant. Okay, so secant theta. This time is theta, right? Theta is terminal. So this time we're going to have some negative numbers. Okay, so listen up. So now this is the terminal. This is the terminal. Okay, this is a terminal. Terminal is theta, terminate OC. So what you have here is that you recognize the terminal, this dot is a point on the terminal, right? By definition, and you recognize X equals to -4, Y equals to -3. Okay, so secant theta is going to be equals to, okay? And of course, you know, R is 5, all right? I don't need to list that one more time. So this is going to be 5 divided by what? X again, right? -4, right? But the kind of answer I give you, which I programmed in, I apologize. I might have caused some of you lose points. In that case, as I'm going over this, you should make an appointment with me or come to my office hours so I can correct my wrongs. So the answer I give for this form is -5 over 4. So if your input is 5 over -4, that is also correct, but it may not have been taken as a correct answer. So I want you guys to go back to your quiz to check if I have, if that mistake have cost you a point. Okay, I just didn't consider that case. You follow me? So the form that the number I will accept, it will be these two forms. I didn't program this in. I did not program this in, which I will do in the future, Okay, so if you enter this number, you may have lost a point. You may have lost 1 point, and I apologize. Okay, now, last one. Did you guys write it down? So go back to check your quiz if that mistake has an impact on your points. And then you come to my office hours and make an appointment with me, then I'll be happy to make that correction. Okay, now, clear. Okay, Now I'm going to give you some other scenarios. Tangent. Tangent. Okay, so this time is tangent sigma again. Okay, so what we have here is that we have the terminal is OD, right? The terminal is OD. So x equals to 4, y equals to -3. Okay, of course, r equals to 5. We don't need r here. We don't need r here. Okay, but we're looking for tangent. We're looking for tangent sigma. Okay, tangent sigma will be equals to, what does that equal to? Y over x, right? Y over x. So what is y? Well, actually, this will be y over x. Yeah, that's fine. So it's going to be -3 over 4. Okay, but the answer I put in the place might be, there are two choices. Might be two choices. Okay, one is -3/4. And the other one would be -0.75. If you input this answer, you might have lost 1 point, but that answer is right. So I will correct my wrong if that happened to you, and please contact me. Okay. All right, so these are the things I want to address. Okay, let's look at one last scenario. I hope, okay. One last scenario. Let's get a cotangent. Yes, cotangent. Cotangent. Okay, cotangent beta. Beta corresponds to the angle of OB. Okay, so you apply the definition, blah, 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 right? So we have x equals to -4, y equals to 3. We don't need r, and cotangent beta. Cotangent beta is equals to, what does it equal to? X over y, right? X over y. So what is x? X is -4. Y is 3. Okay. The acceptable answer in my program is -4/3. And -4/3 only. So if you enter this answer, you may not get the credit. You must enter this number to get the credit. Is there a decimal form of solution? The answer is no. Okay. If you entered, say, suppose you entered -1 point, right? 33. Okay. This answer is considered wrong. You're not going to get any credit as programmed. Do you follow me? Because this is not the precise answer. The precise answer is either this one or that one. But this one was not programmed in the quiz. So if you did this one, you still have a chance to get a point back. But if you did this one, no, you don't get a chance to have a point back. Do you follow me? So once again, I apologize for my oversight in the program, but I am going to take every measure to make sure you get your points back. Okay, so just go back to go over your quiz number 4. Right now it's available so you can see your own response. So what you're going to show me, you're going to show me your own response, and then I will, I will go over that with you. So when you have appointment, will come to my office hour with me. You should be ready for, showing me all of that. I will do the share screen, and then, I will do the counting. We will do the counting together, and you get your points back, no question asked. Okay. So that's all about the quiz. Okay, that's all about the quiz. Last but not least, okay, last but not least, I want you guys to watch this program, because I will actually specify in this class. It's right here. Okay, special triangle and unit circle. Okay, I made this PowerPoint presentation for you for you to understand from the ARD's perspective. Okay, from the ARD's perspective, how this is done. Okay, so I want you guys to watch this program in particular, besides all the other postings I want you guys to read, and also watch this program. Could you do that for me? Okay, because this will show you, because I want you to see from the ARD's perspective, how those triangles are flipped, right? From the first quadrant to the second quadrant, third quadrant, the fourth quadrant, with all those markings, how the definitions are being used. And you realize for the special angles, you don't need to memorize them, because you just need to know 2 triangles, and these 2 triangles are put in different quadrants. Okay, so hopefully if you have any questions, we can go over that next week, because my goal of teaching this class is I want you to see the simplicity, I want you to see the consistency, and I also want you to feel that you don't have to memorize so many things. You just have to memorize, probably it's almost effortless for you to memorize those, a few little things, and then you're all set. Okay, do you understand what I'm trying to do? It's try to help you so you don't you just have to memorize minimal, but you understand a lot. That's my goal. Okay. All right, guys, I will see you on Monday, if not sooner. Okay, so just remember, if you have any questions, you can reach out to me 24/7. Appointment, we'll make appointment, or office hours, and all of that, all of those different venues, by text, pronto, inbox, and I'll be looking forward to seeing you again. Okay, so goodbye today. I will see you guys on Monday, if not sooner. Thank you for coming. I will be opening my office hour link